In this video, I'm going to show you some more optimization problems. So we're going to take a look at minimizing a distance, and we're also going to take a look at maximizing a profit. So this first one here is, I want you to find a point which is on this line, 3x plus y minus 7 equals 0, so that that point is closest to the origin. Now it's nice to draw a picture, so I'm going to put this equation into slope by intercept form so that I have kind of an idea of what this would look like. So I have y-intercept of 7, and then let's say a slope of 3, so something like this. And then there's this point here, probably, that's going to be closest to the origin. All right, so we know that the distance formula between 2 points is x1 minus x2 all squared plus y1 minus y2 all squared. Now, because one of the points here is on the origin, we can actually fill in that our x2 and y2 or x1 and y1 is going to be 0. So now we have that d is equal to the square root of x squared plus y squared, and this is for a point on the origin. Now, a little tip before we do much more is that the distance, so when I want to find the distance, and then if I square both sides, the square of the distance, it actually will have its maximum and minimum at the same point. So let me write this down for you. So the distance and the square of the distance. Now, the reason I want to square is so that I don't have the square root. So the distance and the square of the distance have their max and min at the same point. So therefore, instead of using d equals the square root of x squared plus y squared, I'm actually going to minimize d equals x squared plus y squared. So I can ignore the square root because that point will actually be the same whether it has the square root or not. So now we have d equals x squared plus y squared, and I can see that y is equal to negative 3x plus 7. So I'm going to take that expression and I'm going to substitute in for the y in this expression here. So now I have d equals x squared plus negative 3x plus 7, and that's going to be all squared. And I want to maximize or minimize. In this case, we're trying to minimize this distance, and you'll see that it will be actually. So I'm going to find the derivative. So d prime, or let's say, I guess you could say d, it's kind of a little awkward, but dd, dx, that's going to be equal to 2x plus 2 bracket negative 3x plus 7. Using the chain rule, we need to remember to multiply by negative 3. Set this equal to 0. And we're going to distribute the 2 and the negative 3 into this expression. So we have plus 18x, and then 3 is 6, so that's negative 42. And let's isolate my x's, so I have negative 20x equals negative 42, so x equals 21 divided by 10. So this is my critical point. Now I didn't, because for this question here, there is no restriction of domain because we don't actually know what this value of p is, and it doesn't say there's a specific distance. So x is actually between negative infinity and positive infinity. So when I do a number line test, just to check this out, if I check the derivative on the left of the critical point, I find this is negative, meaning going down. If I check to the right of this critical point, the derivative is positive, meaning that is going or increasing. So actually, indeed, at this critical point, it actually is a minimum. So therefore, the absolute min is at x equal to 21 divided by 10. And we're going to solve what the y value is, because it does say find the point, not just the x value. So we need to plug it into our original. So y equals -3 times 21 over 10 plus 7. And so we solve this to get 7 over 10. So therefore, the closest point is P, which is 21 tenths and 7 tenths. All right, let's take a look at a second type of problem, which is a little bit different. So not distances, but we're actually going to apply it to business and economics. So marginal analysis, it is the approximating of the extra revenue, cost, or the profit from selling or producing one more item. So calculus is important in economic theory so that we can maximize profit or minimize costs. I mean, if we have a business, obviously we want to get as much money as we want, but we want to spend as little as we can. Now let me identify some functions for you. So the letter C, C of x, that stands for our cost. So that's called our cost function. It is the total cost of producing x units of a product. And when we take the derivative of cost, it is called the marginal cost, which is the rate of change of C with respect to x. R of x is called our revenue function. And it's the total revenue from selling x units of a product. And when we take the derivative of R, we get the marginal revenue, which is the rate of change of the revenue with respect to x. Now, a little bit more about revenue. Revenue is actually equal to x times P of x. The x stands for how many units we have, or the number of items of the thing that we are producing. And then the P of x is called our demand function, or the price function. And then capital P of x is our profit function. And this is the total profit from selling the x units of a product. And then when we take the derivative of product, it is called the marginal profit, which is the rate of change of profit with respect to x. Now let's say that we sold x units of an item, then our total profit would equal our revenue minus our cost. So in function notation, this would be P of x equal to R of x minus C of x. So let's take a look at an example where we actually have to apply and use this formula here. So suppose that gadgets are sold at $9 per unit, and the production cost in dollars for X units is given by this expression here, C of X. So the question is, what is the production level that maximizes profits? So meaning, how much should I produce so that I will get a maximum amount of money? In this case, the example, X represents thousands of units. So we know that P of X is equal to R of X minus C of X. So now our P of X is equal to R of X. So what is R? So remember that the revenue is how many units we sell times the price. So in this case, it's not just $9, because that's $9 per unit, but we're selling actually X units. So therefore, our lowercase p, our price, or our demand function, is actually 9x. Okay, so that, so that would give us our revenue. Sorry, not our price. So our revenue function would equal to 9x. So now we have P of x equal to 9x minus x cubed minus 6x squared plus 15x. Now remember to put the minus sign and then make sure that the second function, the cost function here, is in brackets so that you remember to distribute the negative sign inside. So let's do that now, and we'll simplify. So we get negative x cubed plus 6x squared minus 6x we're going to take the derivative of our profit so that we can find the marginal profit. So this would be negative 3x squared plus 12x minus 6. Set this equal to 0 to figure out where this maximum value will be. And in this case, I can actually factor out a negative 3. So I'm going to do that to make my expression a little bit simpler. Now I can't factor this, so what I'm going to have to do is use our quadratic formula. So x is equal to negative 4. So it's going to be 4 plus or minus negative 4 squared minus 4 times a, which is 1, times c, which is 2. So this is our a, b, and c. All of this is divided by 2 times a, which is 2 times 1. So here x equals 4 plus or minus the square root of 8 divided by 2. We can actually simplify this to be 4 plus or minus 2 root 2 over 2. And since all three of these expressions have a 2, we can simplify this to be 2 plus or minus root 2. Now remember that we don't simplify the root 2 because that number is inside the radical, not outside. So if we actually check this critical point here at 2 plus root 2, if we pick a number to the left, we will notice that this is positive. If we pick a number to the right of 2 plus root 2, we will notice that it is negative, so it's decreasing. So this actually shows us that 2 plus root 2 actually is a maximum. So we have 2 plus root 2 equals 9.657 when we plug in. Now I'm actually going to, for interest's sake, let's plug in 2 minus root 2. And that would be negative 1.657. So what happens is that actually if I extended my number line here, let's erase this part here, and put 2 minus root 2, I will notice this is negative and this would decrease. So what's happening is that I have a maximum profit, and that occurs at x equal to 3,414. So that's the value I get when I take 2 plus root 2, okay? And then I have to times it by 1,000, because remember that x represents thousands of units, okay? So this is going to be, so let me put this in brackets. So another way to say this is actually 3.414, okay? And then here, this is 0.586. So when I produce 3,414 items, I actually have a maximum profit, and that profit is $9,657. But there's actually, and there's a loss, so a minimum profit, you can say, or you can call it a maximum loss. And that occurs at x equal to 586 units. So that means I make the most money when I make 3,414 units, but I lose the most when I make 586 units.